welcome to section 3.4, where we're going to be looking at a couple theorems that we can use in order to make life a little bit easier when trying to find a function value and also determining factors of a polynomial. So in this section, we're going to be learning those. Going on, we will also need to learn two ways to divide polynomials before we can learn those theorems. One of those being long division, and the other one is what we refer to as synthetic division. So in the last section, we saw that we could write a polynomial as a product of factors. So we could have had something that was like, I don't know, x plus 2 times an x minus 1 times an x plus 4, something like that. We were setting those kind of equal to 0, finding some x-intercepts and such. We did that in a previous section where we were just focusing on factoring, but in the last section, we actually kind of put some meaning to that. So if we know that x equaling 2 is an intercept of the polynomial, remember, the intercepts came from, in this sense, where we were saying, what makes this 0? What makes that 0? What makes that 0? Here would be negative 2, positive 1, negative 4. And so, if we said that x equals 2 was an intercept, that meant that I had to have a factor in my line of set of parentheses for that polynomial, where x minus 2 ended up being one of those. And so I can multiply that by something inside here in order to get this polynomial that I started with. Now, in that something, that means if I'm starting with just an x here, in order to get an x cubed, that something must have had an x squared in it for us to end up with the highest power being x cubed. So, in order to find that something, that's what we're going to be able to use long division. So basically, what do I multiply by x minus 2? What is that something that when I multiply by x minus 2 kicks out this polynomial here? Okay, just like when I say 3 times 5 equals 15. Well, 3 times what number? In this case, 5. Do I multiply to get my answer? It's the same type of thing. Now, before we do any long division with polynomials, we are going to remind ourselves what is the process when dividing two numbers. So I'm just going to choose, say, like 153, and I want to divide that by 7, let's say. So if I have 153 and I divide by 7, going back to a 4th grade, we would be able to ask ourselves, what do I multiply by 7 in order to get a 1? Or how many times will 7 go into 1? Well, in that case, the answer is nothing. There's 0. So we extend it to, okay, now what do I multiply by 7 that would go evenly or up to 15? Well, in that case, 7 doesn't go evenly into 15, but it can go in twice. Because what we did next was to take this number times that number and place it underneath those first two digits. So when we multiply 2 times 7, we get a 14. And then our next process was that we subtracted those two numbers. So I would take 15 minus 14, which gives me a 1. But I'm not finished yet because I still have some digits hanging out back here, and actually one digit. So we would have brought the 3 down and we start the process over again. How many times will 7 go into 13? Well, in this case, 2 is too many. Therefore, I would say 1. We would again multiply 1 times 7 to get 7, and then I would subtract those two numbers to get 6. Now, when we first started doing long division, we would say, okay, the answer is 21, remainder 6. Remember, this was what we referred to as the remainder, the leftover piece. So we could write it as 21 remainder 6. Yes, we could do that. But then you were introduced to some mixed numbers. And those mixed numbers were found by looking at a fractional value of what's left over out of how many we started with. So we could also, and I kind of do it, always told my students to do it kind of in a circle. This is your whole number, so it would be 21. And then the mixed number comes from taking our remainder over what we refer to as the divider. So 21 and 6/7 would have been my final answer, the more meaningful answer when we were working with numbers. So before we move on to actually showing the idea of dividing by polynomials, let's first remind ourselves of some terms when we were working with division. So I'm going to kind of look at each one of these pieces and kind of talk about how we write the answer. So in our division problem, we are taking kind of the full thing, what we are dividing into, or what are we dividing up, is what we refer to as the dividend. The divisor is what we are dividing by out front. And then that answer was what we refer to as the quotient. So the answer to a division problem is the quotient. Now, we do all of this. We talked about it over here. And down here at the very end is what we refer to as our remainder. Now, how did we get our answer here with that 21 and 6/7? Well, it was the quotient, and we took the remainder over the divisor. Now, in the middle here, without being visible, there's actually a hidden plus, okay? So when we're writing polynomial answers, we're going to take the quotient, and then we are going to add to that our remainder over the divisor, just like what we were doing with that 6/7. But that would be kind of the form that it would take on for our answer. All right? So let's do this idea here with polynomials. Now I'm going to start with the polynomial up in the original part, that paragraph up there. We're going to take that x cubed plus a 4x squared minus a 5x minus 14, and we are going to divide that by that x minus 2 binomial, because what did we say? We said if I knew what that something was, I could multiply it by x minus 2 to get that. So if I'm trying to figure out the something, I'd have to divide by x minus 2 to figure out what that is. And so that's exactly what we're going to do. Now, we are going to take our dividend, which is in the top, and we're going to place that on the inside. Then we are going to divide that by, not very straight, sorry, an x minus 2. Now, here's what we want to focus on when we are dividing two polynomials. Just like with that 7 and that 1, we were looking kind of at the very front digits of that dividend. So we're going to do that kind of in the same piece here with the divisor and the dividend. So we have to just look at these two terms here to determine what goes up top in our quotient. So the question is, what do I multiply x by to get an x cubed back? Or how many times will this go into that? Whichever way that you look at it, I hope you're telling me that I need two x's there, or an x squared, in order to get an x cubed. So that when I multiply, which was our next step, right? We took that 2 times the 7, brought it down here, and subtracted that. So that's exactly what we're going to do here. We're going to take the x squared times the x minus 2 and place it under here. Now remember, when you're taking one term, multiplying it by 2, we have to distribute that through. So x squared times x is an x cubed. Then we're going to multiply x squared times a negative 2, which gives me a minus 2x squared. Now, in our example above, once we multiply, the next step is to subtract. But if I'm going to subtract something, and more specifically, I'm going to subtract this expression here, if I'm going to try to find a little spot here, subtracting x cubed minus 2x squared, remember, I have to subtract the whole thing. And when we have two terms, that's very important to remember that you must distribute that negative through, okay? So basically, in layman terms, what happens is that the signs of these two terms will change. If I'm going to subtract, that means I have to change the sign on both of those. If I were to distribute, this would be a minus x cubed plus a 2x squared, which is exactly what I have right here. All right. If these two terms do not cancel and go to 0, you have done something incorrectly, okay? These two will always cancel. Now we're going to add these two. We're going to do 4x squared plus a 2x squared and give us a 6x squared. But I've got a couple terms back here, so that means we have to drop that next term down and do it all again. So we are going to focus on our first terms here. What do I multiply x by to get a 6x squared? Well, if I take one of those x's away, that leaves me with a 6x that I need within my quotient. So again, I'm going to multiply 6x times x to give me 6x squared. I'm going to multiply 6x times a negative 2 to give me a minus 12x. The next step that we have to do, again, what did we do? We subtracted, and when we subtract those two binomials, both signs change. So this becomes a minus, that becomes its opposite, which in this case is a plus. Now, let's go ahead and combine like terms. This goes away. 6x squared minus 6x squared is gone. If that doesn't cancel, you've done something wrong. Minus 5x plus 12x gives me a 7x. And then I have one more time that I have to bring down that term. So we end up with a 7x minus 14. And we do it one more time. So what do I multiply x by to get this 7x right here? Well, that has to be a plus 7. So plus 7 times x is a 7x. Plus 7 times a negative 2 is a minus 14. And one more time, we have to change the signs here. Make that a minus, make that a plus. That goes away. And when I add this together, negative 14 plus 14 is a big fat goose egg. So the remainder of this is actually 0. So the answer, the quotient, is this x squared plus 6x plus 7. But again, what is this meaning that we are finding? It is taking this x minus 2. If I were to multiply it by this quotient, I would end up with what I started with. And that's the goal, is to be able to figure out the leftover piece. Okay? All right, let's try the next one. The next one, we have 2x cubed minus 7x plus 3. And I'm dividing that by an x plus 3. So notice here, I'm starting with another cube. But I'm hoping you're seeing something that's kind of missing here. When we talked about polynomials and descending orders of x's, that means I looked at the powers and I wrote them from the highest to the lowest. And the lowest would be your constant. So we're starting with a power of 3, then a power of 2. This is our invisible power of 1, and technically that's an x to the 0, so a 0 on that one. It is crucial that when you're doing long division or if you're doing synthetic division that you have a placeholder if there is a term that's missing. So notice here I start with an x cubed and then I go down to just an x term. So I actually have a term that is missing there. So I need to put a placeholder in there. So we're going to start with our little bar here and then we're going to write our 2x cubed. But because I have an x squared term missing, I'm going to do a placeholder of a 0 there. Then I'm going to do my power of 1 and then no power with our constant at the end. So then I'm going to divide that by an x plus 3. That is my divisor. And now we are out to find what do I multiply x plus 3 by to get this back. And that would be my quotient that I get. All right, so here we go. What do we multiply x by to get a 2x cubed? Well, I need a 2. And I take one of these away, leaving 2. So a 2x squared would be what I have there. Multiply that by each of these terms. So 2x squared times x is 2x cubed. 2x squared times positive 3 gives me a plus 6x squared. And now, after multiply, we subtract. So I'm going to change the signs. Now this one becomes now a minus. So I kind of usually just scribble out that plus. Then we're going to cancel these first two terms, which they do. Double check that that works. And then do a 0x squared minus a 6x squared gives me a minus 6x squared. I have another term that I'm going to bring down. And I start the process over again. What do I multiply x by to get a negative 6x squared? Well, first I need this number, and I'm taking one of these, so that better be a minus 6x that I multiply by x to get this negative 6x squared. So let's do that. Multiply negative 6x times x is minus 6x squared. Multiply negative 6 times a positive 3 gives me a negative 18x. And then we have to subtract. So now when we draw our line, we're going to switch the signs of the second terms there by making that a plus and that a plus. These end up canceling, which is good. And now I have to figure out what is negative 7 plus 18x. So negative 7x plus 18x looks like an 11x. And I check my polynomial. I have one more term to complete. So bring down that positive 3 and we start over again. What do we multiply x by to get an 11x back? Well, in that sense, I need the plus 11. Take the x away. The 11 is left over. Plus 11 times x gives me an 11x. Plus 11 times a positive 3 gives me a plus 33. And when I do that, time to subtract means I switch this sign and I switch this sign. And now these cancel, leaving me the answer of 3 minus 33, which is actually a negative 30. That is our remainder. Don't forget that's your remainder. And now, how do we properly write our quotient? Now, let me scroll up real quick. Remember this here? I take my quotient, which is this piece, plus the remainder over the divisor. So we're going to take our 2x squared minus 6x plus 11. Then I'm going to add to that my remainder, negative 30, all over the divisor out front, which is an x plus 3. Now, that is a perfectly okay answer. The other way to write that is to bring the negative in front of the whole fraction. So these would stay the same, but if this is negative, you could do plus a negative, and that could change to a minus 30 all over an x plus 3. So I don't care which answer that you give me. Either one of those would be correct. Okay? All right, very good. So that's kind of the long version, aka the long division. Let's now turn our attention on the back side of this note sheet to what we refer to as synthetic division. So anytime that you're dividing polynomials, when in doubt, you can always use long division. But mathematicians are always famous for the shortcuts, that if we know how to do that the long way, if there's a shortcut, we'll probably take it, okay? And so we are going to use synthetic division on any problem in which you are dividing by a binomial of the form x minus c. So it is a linear term with a power of 1. C is just a number. C is a member of the real numbers. More than likely, it would be an integer, a plus or a minus whole number. And so this is what we are going to refer to as synthetic division, okay? And we're going to do this by example. Now, what we have to do is out front, we have to put our c values. So down here, this is what I'm dividing by. So that x minus c is in the divisor. So because there's a minus here in the general form, then we have to take the opposite of what our eyes are looking at when it's grouped with the x. It doesn't say x equals, it tells me x minus 2. So there's my minus, therefore that piece is my c. So my eyes are looking at it and I see a minus 2. The c out front is actually going to be a positive 2. That will be the opposite, okay? Now, we're going to look at our dividend, and we are going to write out the coefficients of that dividend, making sure that if I have anything missing, I don't forget a placeholder of 0. So coefficients are the numbers out front of our cubed, our squared, our linear, and our constant. So I'm going to put a 1, then I'm going to put a 4, then I'm going to put a negative 5, and then end with negative 14. So notice that if I have a negative, make sure that you take that with you, okay? All right, here we go. We're going to do this by example as well. First thing that you do, you are going to bring down the 1. Okay, let's see if I can do a different color here. Bring down this 1. Nothing changes in that sense, so I'm going to bring down the 1. Now, what I need to do here is to multiply that 1 by c. So 1 times the c out front, which is 2. I'm going to multiply 1 times 2 to get 2. If I can do all these color changes, okay? Then the next thing I'm going to do is I'm going to add these two terms. Okay, so 4 plus 2 gives me a 6. Then I'm going to start that process all over again. I'm going to now multiply this by c. 6 times 2 gives me a 12, and that's the number that I want to put underneath that negative 5. And then I'm going to add those two numbers again, just like before. Negative 5 plus 12 ends up getting me a positive 7. Then I'm going to, one last time, because I'm not finished yet, I'm going to multiply by c, and then when I do that, 7 times 2 gives me a 14, and then I'm going to add those two numbers to get my final answer for this, as 0. I did so good until I got to the end. All right, there is my 0. All right, so this, if you flip over your page, is the polynomial that we started with, and we did the very first one there on our first page in the long division. That was the same problem. So I'm doing it the same problem two different ways here. So notice, what did we get as our remainder? Remainder was 0. Come back here. Where is that 0? It is right here. So I will tell you that the end number will always equal your remainder. Now, if I start with an x cubed and I divide by an x, so this is an x cubed. anytime you do this division with a power of 1 in the bottom, power of 3 divided by power of 1 leaves me with 2. So that leaves me with an x squared. So what I have down here are the coefficients of the quotient. So 1 power less gives me an x squared, so I get 1x squared plus decrease the power by 1 gives me a 6x, decrease the power by 1 gives me a 0, which actually is that constant. So the quotient for this problem is x squared plus 6x plus 7. Okay? All right, let's try the next one. The next one, we're going to do the same idea. We need a c out front, and that c comes from taking the opposite of what I'm looking at in the divisor. So I see a plus 1 because, again, in our general form, that's a minus there. I need to take the opposite. So actually, c out front this time is a -1. I'm going to write all the coefficients of my dividend, and in this case, I have a power of 3. I have a power of 2, but I actually have a missing power of 1. So we need a placeholder, so you might want to write on there to remember placeholders. So I'm going to start with a 5, then my power of 2 is -2, then I'm missing the x, and I end with a 1. So here we go. By example, I'm going to bring the 5 straight down, so I get a 5. Multiply by c, so multiply by -1 gives me -5. Add these two gives me -7. Multiply by c to give me a +7 because -7 times -1 is a +7. Then I'm going to add to that, and then we're going to multiply again and add. So that gives me a -6. Now that, again, is the remainder. So this time that means that I have this quotient. If I'm starting with an x cubed and I divide it by an x, that means that better be my x squared. So 5x squared minus 7x plus 7 with my remainder over the divisor becomes -6 all over an x plus 1. Now again, you could write it where you end up having +7 plus a -6 over x plus 1. So I don't care where you put the negative, either in the middle of them or on the top of the fraction. But that would be our quotient. So if I take this and I multiply it by x plus 1, I get back what I started with. Okay? All right, so those are the two strategies that we're going to use to do some division. And actually, that's going to be the synthetic. Hopefully, you're going to get a lot more practice on because we use it quite often. All right, we're going to get into those two theorems that I talked about at the very beginning. One called the Remainder Theorem, the other one called the Factor Theorem. And the Factor Theorem is actually going to be able to help us to solve some of these polynomial equations, okay? Now that we've learned how to divide two ways, let's use these strategies in application. So, the Remainder Theorem says this. If I have some polynomial p of x, and it is a polynomial of degree 1 or more, and c is a real number, then when p of x is divided by that binomial x minus c, then the remainder is equal to p of c. Now, let's talk about that notation. That notation p of c means that I take that number and I plug it in for c, or plug it in to my function, actually, for x, and then I work it out. So, like, for instance, here, if I said, what is f of 3? F of 3, that means when x equals 3, the old school way was to go ahead and sub that in for every single x. I would have to cube it, square it, then multiply it, add and subtract them all together. And that just takes a lot of time. So, by our remainder theorem, the remainder theorem is very nice because if the remainder is equal to p of c, then when I ask to evaluate a function at a certain number, all I'm worried about is the remainder. That is the function value at that point. So, for example, if I have this function, and instead of plugging 3 into each one of those, I'm going to use a little synthetic division to do that. Now, notice this says x equals 3. It's not x plus or minus that 3 like we had before and had to take the opposite of what we were looking at in order to find that c. Take the opposite to find c. Here we're going to use that number. That is the C, okay? So we're going to use that out front. I'm going to line up my coefficients with the power of 3. I better have 4 numbers written down here. If not, make sure you add in some placeholders. I'm going to bring the 1 straight down, multiply by C to give me 3. Add the 2 gives me 7. Multiply by C gives me 21. Add the 2 gives me 19. Multiply by C gives me 57. And add the 2 gives me 52. So I don't care about any number in that work except for the remainder. So if I say to find that function value when x equals 3, all I care about is that number. So instead of plugging in cubing, plugging in squaring, multiplying by 4, plugging x equal into this x equal and multiplying by 2, and then adding and subtracting all those values together, I can do this real basic synthetic division, steal the remainder, and that is my answer. Okay? All right, let's try another one. Here we're finding f of negative 4. So what is f of negative 4 when I have this function? So again, instead of plugging negative 4 in, let's do some synthetic division. Now this time, I have a power of 4. So I better have 5 numbers. It's always one more than the highest power. I better have 5 numbers for my coefficients. Well, here's the power of 4, which the coefficient is an invisible 1. I do not have an x cubed, so I better throw a placeholder for 0. Then I have a negative 2 for my squared, 3 for my power of 1, and negative 10 for my constant. So here we go. Not that it's hard, you just have to be meticulous. Bring the 1 straight down. Multiply by C gives me negative 4. Add gives me negative 4. Multiply by negative 4 gives me 16. Add gives me 14. I almost said negative 14. Multiply 14 times negative 4 is negative 56. Add gives me negative 53. And one final time, multiplying by negative 4, I get 212. And when I add, I get 202. So again, by the remainder theorem, I don't care about anything else but that guy right there. If I were to plug in negative 4 to all those x's, multiply it, do all the powers, I'm going to get 202. Pretty slick. Okay? Maybe. All right, there we go. All right, next. Another way we can use division of polynomials is to break them down so that we can figure out our factors of that polynomial. And those factors will actually then create our x-intercepts that we can actually solve for that function. We can also use those then to graph. So it leads us into all different kinds of things that when we're working with those polynomials. Now, in order for a polynomial to be a factor of another polynomial, then your remainder better be 0. So anytime you have a remainder of 0, that means that whatever you're dividing by goes evenly into that. So that's why if you look at 7 into 153, if you remember we had a remainder of 6, 7 would not be a factor of 153. But if I look at 5 into 155, because it ends in 5, 5 would have a remainder of 0 because it is a factor of that number, okay? So the same idea with polynomials. So let's get our definition and then we will go through and try some of these problems. So the factor theorem says this: if p of x is a non-zero polynomial, then our real number c is a 0 of that function p of x if and only if x minus c is a factor of that polynomial p of x. Now, I like to look at it in layman's terms. AKA, if your remainder equals 0, that means you have a factor. Okay, again, just like before, we didn't care anything about any number except for the remainder up here. We don't care anything about any other number except for what remainder I kick out at the end. So we're back to this grouping with the x. So it's not saying x equals that this time. So we have to take the opposite of what we're looking at. C here is that negative 2. Okay? Now, notice here I have an x cubed, but I need one more than that power of 3 for my coefficient. So I have missing terms in there. Coefficient of 1 for my x cubed. I don't have an x squared term, so I need a 0. I don't have an x term, so I need a 0. But there is my constant, which is 8. Always one more number here than the highest power in your polynomial. All right, so here we go. Bring your 1 straight down. Multiply by c gets -2. Add gives me -2. Multiply by -2 is 4. Be meticulous because you can make a negative error. 0 plus 4 is 4. Multiply by -2 is -8. Add gives me a big fat goose egg. And because that remainder equals 0, that means that this is a factor of that. Yes, because the remainder equals 0. Okay? So if I ask why, you're going to have to tell me that. You also want to probably show your work on that as well. Okay? All right, let's try this next one. We have a power of 4. That means I need 5 numbers, and I'm looking and missing an x cubed here, so don't forget your placeholder. What is the number out front? Well, since it's grouped with x, we take the opposite of what our eyes are seeing. Therefore, it's a -1. Put our coefficient of 1 for our fourth, but we don't have a third, so we want a placeholder. Then we go -5, 8, and 10. So here we go. Bring your 1 straight down. Multiply by c gives me -1. Add gives me -1. Multiply by -1 gives me +1. Add is a -4. Multiply by -1 gives me a +4. Add gives me a 12. Multiply by -1 gives me -12. And add gives me -2. By the factor theorem. I don't care about anything else except for that guy right there. There is my remainder. No, this is not a factor because our remainder does not equal 0. If it's any number besides 0, -100, -2, 500, it doesn't matter. That is not a factor. Okay? All right. Last page here. We're still going to use some synthetic division. But we are actually going to go further a little bit and actually find our zeros for our functions, okay? So it's asking us here to determine the quotient, which we've done. That's the last line of each one of these. This is the quotient, and we can translate that into each power. Then we are going to use that idea to write out factored form. So we know if this goes in evenly, that is technically a factor. So we would include that in our factor form. And once we have that for finding our x-intercepts, then we can set each one of those factors equal to 0 and solve for the numbers that make that true. So our first line of business is to divide this into that. Because it is a power of 1 with that number, we can use synthetic division. If it's grouped with the x, I have to take the opposite of what I'm looking at. So therefore, my c out front is -2. All right, now, coefficients. Notice I have a fourth, a cubed, a squared, a 1, and nothing. So I have no placeholders this time. I can worry about just writing out those coefficients. Okay? Bring the 1 straight down. Multiply by c gives me -2. Add gives me -4. Multiply by -2 gives me 8. Add gives me -1. Multiply by -2 gives me +2. Add gives me 4, and I'm hoping if that's a factor that I get a big fat goose egg here. Multiply by -2, which gives me -8, and when I add, most definitely, there's my remainder. So that proves to me that x plus 2 is a factor. So I have to make sure that I include that in my factored form for my polynomial. Now, the quotient, again, is our answer to that. So now notice we started with an x to the fourth. Notice I divide by an x to the first. So if I divide by 1x, then I end up with an x cubed here. So it's always 1 less than that when you're doing synthetic. So what is the quotient? The quotient is that x cubed minus 4, that would then be our x squared, minus 1x, I'm not going to write the 1, so minus x plus 4. That's the quotient. But we have to figure out what the other somethings are, okay? So I'm going to write it starting as my factored form here. X plus 2 times that x cubed minus 4x squared minus x plus 4. Now, the question is, if I'm doing this, hopefully I know how to factor this piece here so that I can get my factored form. So I'm going to rewrite this. And notice we have 1, 2, 3, 4 terms, which the strategy to factoring 4 terms is that I'm going to do some grouping of 2 by 2. So I need to take out anything that's in common with these two, which is actually an x squared. What do I multiply x squared to get x cubed back? It is an x. What do I multiply x squared to get a minus 4x squared? That's a minus 4. And in a 2 by 2 grouping, we are hoping that what comes out of this, as I factor out common terms, will leave me with an x minus 4 that is going to be common to both this term and this next term. So notice it's very similar to an x minus 4 except for our signs are different. So if I take out a negative 1 or just a negative x, or a negative, excuse me, not negative x, sorry, just take out a negative. Remember, if I just FOIL in a negative or I factor out a negative, all it does is change the signs of these. So that makes that a positive x, and this positive 4 then turns to a negative 4. All right, do I have common expressions this time? Most definitely between this term and this term. The x minus 4 is the same, so I'm going to bring that out front. And I'm left with what is in front of those parentheses. What do I multiply this by to get this all back? I need an x squared. What do I multiply this by to get this back? Well, I have that x minus 4. I need that minus 1. So those are going to be my factors. We have to ask ourselves, are we finished? Can I go further? Well, power of 1? Nope, can't go further. Power of 1? Nope, can't go further. Come to a power of 2. Can I go further with that power of 2 when I have two different terms and a minus between them? I'm hoping you're screaming at me, yes, you can, because hopefully you recognize that as a difference of two squares. Those difference of two squares, that was that a squared minus b squared, and it factored into two binomials that were exactly the same except for their signs, an a plus b and an a minus b. So I need a plus and a minus, and splitting up my x squared gives me an x and an x. And what do we multiply to get 1 that we multiply by itself? It is a 1 and a 1. So there is my complete factored form as an x minus 4, then an x plus 1 times an x minus 1. Okay? So factor it all down completely. And once I have that factored form, if I was asking for the zeros, technically we would set that equal to 0, and we would say, what makes this 0? Well, if we're finding zeros, that means x has to equal a negative 2. What makes this 0 is a positive 4. What makes that 0 is a minus 1. And what makes that 0 is a positive 1. And those would be our zeros, or our x-intercepts of our polynomial. Okay? All right, so we're going to kind of do that idea again, where now we're going to actually just work with cubes. Oh, here's a fourth over here. But I'm going to give you the answer, okay? So I'm giving you that 1 is a root, 1 is a 0, 1 is an x-intercept of this polynomial. Now, from previous sections in Chapter 3, we learned, I believe it was Section 1, that if I have a power of 3, the maximum number of zeros that I can have equals that number, which is 3. So here, if I'm solving that polynomial, I need the 3 answers that make that equal to 0, okay? Solving that polynomial, I want to know when that's equal to 0, and so let's see what we can do. Well, they already told me that 1 is an answer. And if 1 is an answer, that means that when I throw that in here, I would get 0. But if I'm throwing that 1 in here, we could also do some synthetic division on there, getting a remainder of 0 and breaking it down to where I can get something that I can actually solve or factor possibly. So let's do that. Let's break it down from our cube. It's like we're going to be dividing now by that x minus 1. So we're going to look at our coefficients here of 1, negative 6, positive 11, and negative 6. Nothing missing, no terms missing, no placeholders. Bring your 1 straight down, multiply to get 1, add gives me negative 5. Multiply to get negative 5, add gives me 6. Now, if it's a root, this better have a remainder of 0. When I multiply, I get positive 6. Add gives me 0. Ding, ding, ding. That tells me I definitely have that factor. I've done this correctly. If I have an x cubed here, that means when I divide by your root or your x minus 1, this now becomes an x squared. So the quotient here, if I write it all out, becomes that x squared minus 5x plus 6. Now, if I want to know when it's equal to 0 to completely solve that, actually I can set it equal to 0. The question would be, how do I factor that? Or I can complete the square with that, or I can use the quadratic formula, and we've discussed all of those earlier in chapter 3. Very nice if I can factor, and actually this one does factor. A 3-term trinomial can factor into 2 binomials. Remember, if the last sign is a plus, they are the same that match the first. And we're going to split up our x squared as an x and an x. And with our number of 1 in front, what do we multiply to get 6 that we add to get 5? What do we multiply to get 6 that we add to get 5? And that is a 3 and a 2. So, along with 1 as an answer, what makes this 0? That would be a 3. What makes this 0? That would be a 2. Therefore, in addition to the one they gave me, 3 and 2 would solve that equation, and that would be your answer. Those would be your roots. Those would be your x-intercepts for that. Okay? All right. And our last problem is talking about the same idea of solving a polynomial equation where we want to find out where it's equal to 0. But this time it says that we're given that 1/2 is a 0 with a multiplicity of 2. And remember, a multiplicity of 2 just means that I have that binomial that occurs twice. I would have that power up here on that binomial. So that just means that 1/2 occurs twice as a root. So how many answers am I going to kick out? Well, I'm going to kick out 4 total. And with a multiplicity of 2, technically that 1/2 occurs twice. So I'm out to find the other 2 that make that work. So let's do this. We have to synthetically divide with each of our roots. These just so happen to be the same. So I'm going to take my coefficients, power 4, 3, 2, 1, nothing. So I don't need a placeholder. All right, so there's our 5. We're going to bring this 4 straight down. 1/2 of 4 is 2. Add these 2 gives me negative 26. 1/2 of negative 26 is minus 13. Add these 2 gives you 48. 1/2 of 48 is 24. Add these 2 gives me negative 18. I better get a negative 9. Is 1/2 of negative 18 negative 9? Most definitely. Adding these 2 gives me that remainder of 0. So if you know these are roots and you don't get a 0 here, something is wrong in your calculation. So make sure you go back and check your work. All right, now, remember, this was x to the 4th. And if I divide that one time with my root, that means that I'm now down to an x cubed. Well, if I were to try to write this 4-term polynomial out, I'm not going to be able to kind of do a 2-by-2 grouping, which you may or may not be able to do that. But if I know a second root, instead of just kind of starting over, we're going to start here now. And if I have an x cubed and I'm going to break it down one more time, that means what I get in my answer is going to be an x squared. Okay? So we're going to erase that for a minute here. Bring your 4 straight down. Do it all over again with these 4 terms. 1/2 of 4 is 2. Add these gives me negative 24. 1/2 of negative 24 is minus 12. Add these gives me a 36. 1/2 of 36 is 18. Negative 18 plus 18 is my big fat remainder of 0. And so yes, here we go. That now gets us our factors. So I know that 1/2 and 1/2 are actually roots. And what I now need to focus on is this remaining quotient. Now remember, if that's x to the 4th, this was x cubed. Therefore, one more time says that has to be x squared. So if I have 4x squared minus 24x plus 36, and I want to set that equal to 0 to solve, we can do that all day long. Now remember, what's the first rule of factoring? The first rule of factoring is to take out any common terms. So notice with 4, 24, and 36, there is actually a common number of 4. So We can factor that out, or because we have it equal to 0, we can actually just divide by that 4. Because 4 will never equal 0, therefore it would never kick out a root. But it does allow me to break these numbers down a little bit better so that I can factor it a lot easier. Okay, so we end up with x squared minus 6x plus 9. Again, we're back to a trinomial so that I can factor into two binomials. Last signs of plus that are the same that match the first inside. Split your x squared up. And now what do we multiply to get 9 that we add to get 6? What do we multiply to get 9 that we add to get 6? And that is a 3 and a 3. So these two things just so happen to be the exact same numbers as well, creating a double root here of 3's and making my final answer for this problem to solve basically 1/2, 1/2, 3, and 3 are our answers. Now, you can write it that way. Some people will write it where it is just 1/2 and 3, and that would be the most widely spread. Normally, you don't repeat those roots if they are the same. There are sometimes when books will designate those as what we refer to as double roots because they do occur twice, and you have to have that power of 4, have to having 4 answers there. And in this case, they just occur twice. Okay? All right, very good. So that's what we have for section 3-4. Make sure you can long divide. Make sure definitely you can do your synthetic division and apply that with not only being able to find zeros, but also to use it for the remainder theorem and the factor theorem. So until next time.